All right, 4647, the product of a sum and a difference. So let's go over this real quick and let's actually just do the math. A plus B times A minus B. So this is much like what we talked about in the last section. We're just multiplying these two binomials together. So when we multiply the A, we're going to multiply the A times the A and the negative B. So A times A is positive A squared. Positive A times a negative B is a negative AB. You can't really multiply different variables. And then we're going to distribute the positive B here. So positive B times A is a positive AB still. Technically, you can reverse that order and say AB or BA. It's the whole idea of 2 times 3 is the same thing as 3 times 2. It doesn't matter the order of those specific terms. And then positive B times negative B is a negative B squared. But what we want to see here when we multiply the product of a sum and a difference, those inside terms are going to cancel out. And we're left with this as an expression, A squared minus B squared. So these two factors that we multiply together, these two terms are called conjugates. And that's a vocab word you need to become familiar with. So conjugates are just two identical factors. One is a sum and the other is a difference. And you see the answer ends up just being the first term squared minus the second term squared. So if you're doing the FOIL method, the OI, the O, the I part, those cancel out. And you can see that's what we have here in all these examples. We're multiplying these to form an equivalent expression. But you'll notice these are all conjugates. Even this last one, so it's pretty obvious with part A and part C because it's the exact same term and those middle signs are different in all of these, but you could rewrite part C. We could rewrite this as 4 minus, in fact, let's do that. 4 minus 3z squared times 4 plus 3z squared. So when you do that, it's a lot easier to recognize that those are conjugates. So let's do one of these the long way and the rest the short way. So part A, those are conjugates. So I'm going to distribute the x. X times x is x squared. And x times positive 8 is positive 8x. And then I'm going to distribute the negative 8. So negative 8 times x is negative 8x. Negative 8 times positive 8 is negative 64. So every single time you multiply conjugates together, those inside terms cancel out. And we're left with x squared minus 64. Or in other words, we multiplied the two first terms together, and then we multiplied the two last terms together. And that's the shortcut if you recognize they're conjugates. They're not always going to be conjugates. Of course, all of these are. So let's do that on this next one. We're just going to multiply the first two numbers to get 49, and we're going to multiply the last two numbers. A negative times a positive is a negative 9x squared. And really, that's all we have to do once we recognize that those two factors are conjugates. Try C and D. Pause the video. I'll show you the answer here in just a second. There's part C. 4 times 4 is 16. Negative 3 times positive 3 is negative 9. Z squared times z squared is z to the 4th. And then here's the answer to the last one. 5 times 5 is 25. X squared times x squared is x to the 4th. Positive y squared times negative y squared is negative y to the fourth. Again, this shortcut can only be implemented if you have conjugates.